So the first topic is introduction. So what is Java? So Java, as we said, it's a program.
One of the most fundamental programming languages that anybody can learn. Despite being so simple, it is a marvel what can be achieved with the use of Java. Hi everyone, I welcome you all to this Java full course session by Edureka. But before we begin, let's look at our agenda for today. So we're going to start out by talking about Java, what it is and why do we need it. Then we're going to discuss a few basic concepts like variables and data types in Java, followed by which we are going to talk about operators, control statements, and methods. We are also going to discuss the meat and potatoes of this session, classes, objects, and object-oriented programming concepts in Java, followed by which we are going to talk about exception handling. Then we are going to discuss Java collection frameworks and finally close this session by
Is about introduction to Java. So what are we going to cover in this particular topic? So it's going to be introduction to Java, what Java is all about. Uh, we'll have Java installation done as well so that you guys can use it in future. You guys can try your hands on. We'll talk about modifiers and variables in Java. This is pretty much similar to what we have in other programming languages. We'll talk about Java data types as well, which is nothing but data type as we have. It's a storage for different data types, right? Or the data that is stored, whatever you want to process on, is first put into memory, and that is what data type is all about. So you have different storages, like for character, you have something else, and for float, you will have something else. For long, you will have something data type conversion in Java. So you could convert from one data type to other data type in Java. There are implicit conversions done wherein the programmer need not take care about it. Java programming by itself would take care about converting it, which is implicit conversion. And there are few conversions which programmers have to take care about. They have to explicitly mention that you have to convert from this data type to this data type, and if you don't do it, you would end up in compilation errors or something. We'll talk about operators. Operators are nothing but the operators that work upon this data type, and which is nothing but transformation. So you kind of use this operators to add up. For, say for example, you have two integers, you want to add it up, so you would have these operators used. We'll talk about control statements in Java as well. Control statements like you have if else and for loops and stuff like that. So we'll talk about it. So Java is pretty much similar to other programming languages. Thing is, it has some unique features which makes it really important in the current industry, in the IT industry, when it comes to big data and stuff like that. So we'll touch base on all these important features of Java, which would help you to understand why do we really use it. All right. So the first topic is introduction. So what is Java? So Java, as we said, it's a programming language which has object-oriented programming model. So when I say object-oriented programming model, everything in Java is taken as an object. So object is nothing but something that has got state and behavior. Say for example, you have chair, right? So chair has got a particular state and it has got a particular behavior. if you do something, if you move it, it would go this way and that way and stuff like that. So basically, any object, if you think about in reality realm, any object for that matter would have some kind of state and it would have some kind of behavior which incorporates on its own, right? So basically, similar to that, Java is programming language which is based on object-oriented programming model. So everything Java could be thought of as an object, or you define a class. So say for example, you have house, right? So house could be thought of as an object or class rather. A house is a class and it would have certain attributes, right? Like number of rooms or stuff like that. So that is nothing but the state of the house. So this was actually brought in by Sun Microsystems in 1995. And basically Java is nothing but we have JVM, but JVM is nothing but you kind of can say it's a specification, right? Sun Microsystems has said that this is how it should be. So that any company tomorrow I can go and create my own version of Java, but it has to be aligned to this particular specification that is given by Sun Microsystems. So Java is nothing but the reference implementation of Java is provided by Sun Microsystems, but nevertheless, as I said, JVM itself is a specification which anyone can implement actually. But we will talk about Sun Microsystems, talk about the reference implementation that is nothing but one created by Sun Microsystems. So everything in Java would have a state and behavior, and which would be defined by class. Again, it was started off by a team led by James Koshling. And we know it's an open source, which doesn't stop anyone from putting in whatever code they want to. Still, we have a lot of versions coming in Java. So it's not that you just have one version created by Sun Microsystems and it's been used across the industry. You have like, if you find some issues or if they want to have some kind of enhancement in a particular module, they keep doing it. So right now we have like Java is at version 12, which is like we have a lot of enhancements coming in. It's a evolving thing. It's ever evolving thing. And as I said, this is open source. Tomorrow, if you become a good programmer in Java, you could go and actually write something for Java and which would be moderated by someone and which would be put as open source and anyone can use it. Other thing is Java, the very important feature why we use Java or why Java is so widely used is write once and run everywhere. So you write a class or you write program once and you compile it, and this particular compiled version of class could be run anywhere on any machine, or you could transport this particular compiled version of Java, which is nothing but class file. We call it as a class file. Again, you did not get into what is class file, but just to say that you compile it, you get a compiled version of it, and this compiled version of class could be transported anywhere in the network, or you could put it anywhere and just run it. So you could take it on your pen drive as well and go anywhere and plug your pen drive, get this class path, download this class path, or download this class rather, and just run it. So it write once and run everywhere. And the magic part is it could be run on any environment. It could be run on any platform. That's is going to run. It could be on any platform. So this is why it is more important. So unlike .NET, right, you need to have Microsoft. Just to give you this thing comparison with .NET. So for .NET, you need to have Microsoft Stack implemented, but for this, you need not. It could be run everywhere. So Java can be used to create complete applications that may run on a single computer or can be distributed among servers and clients in the network. As I said, this is more about the application of platform independent programming language. So it's pretty much similar to other programming languages and it's verbose. So anyone can just read through it and understand what it is trying to do. So they have kept it to that level. So similar to any high level languages, right? The code should be such that as you read through it, you should understand what it is doing. And that's what they have tried to do. It's high performance, one of and what it is. is doing, and that's what they have tried to do. It's high performance. One of the things that I already mentioned about, it's the evolving system. It's not that it's been just done once and been used throughout. It's a evolving system. So as and when there's continuous improvement done, right? So as and when, if I as an application programmer, if I find something not working as expected, I can raise a ticket. And they could go through the ticket, or there's a Java development team which has been driven by Oracle now. They would look at the priority of this particular stuff, and if there are a lot of tickets being raised by other companies as well, and if something could be done on the particular aspect that you raised, they would surely incorporate it and notify you in a particular release the enhancement is coming up and stuff like that. So it's a evolving system, and the performance is always, if there's some drawback or if there's something not working as expected, they would surely rectify it in the future releases. So that way they keep it up to the mark. They keep the high performance thing going. It is secured. So Java basically runs in virtual machine sandbox, and no one can get into this particular space. So no one can intrude it, I would say. So that keeps it free from virus and stuff like that, or untrusted process. And other thing that is important is, unlike C, Java doesn't expose pointers. So in C, there could be malicious user who could get into the memory location through pointers and can manipulate the contents of a particular memory, right? Whereas in Java, it doesn't expose the pointer. It doesn't give you the pointer to a memory location. So you can't actually go and change the content of a memory location when you're using Java. So that keeps it secured. So it's robust. So Java checks the code during compilation time and runtime. So basically what happens is, as I said, when you compile it, you get a class file. And whenever you this, as I said, you expose the pointer. It does doesn't give you the pointer to a memory location. So you can't actually go and change the content of a memory location when you're using Java. So that keeps it secured. So it's robust. So Java checks the code during compilation time and runtime. So basically, what happens is, as I said, when you compile it, you get a class file. And whenever you try to run this class file on any of the machines, it will ensure that it's properly done. Or if there's some issue with the class file, it would say that it's a corrupted class file. So basically, you have some kind of checks done during the compilation as well. Compilation is nothing but if you have some syntactical error, say for example, if you miss a semicolon at the end of a particular statement or an end of any statement, it would prompt you during the compilation time that this is not what is expected, or it would ask you to correct it. Once you have everything as per the expectation, it would compile it and create a class file. And when you port this class file to any of the machines, during the runtime, it checks as well. And the other thing is about you don't have to take care about memory allocation and releasing, unlike in other programming languages. Java by itself does garbage collection. Garbage collection is nothing but when a particular memory is not being utilized by your program or goes out of scope, it would Java by itself has a thread. I don't want to get into threads and stuff like that, but Java would clean off the memory contents by itself. You don't have to explicitly write a code to clean it. In C, you have to write a code to clean it, whereas in Java, it's done by itself. So that makes it robust. Other thing is it's portable, as we already spoke. You can write a program in Windows and you can run the same program, or you can write a program in Windows, compile it, get a class file or the compiled version of the class, and just port it on any platform. It could be Windows, it could be you run it on Unix or Linux or Mac or anywhere. So you don't have to take care about it. So Java by itself does it, and that's where JVM comes into picture, which we'll talk about in the further slides. So other thing is it's dynamic, which means that it has runtime polymorphism. So all the objects are evaluated during runtime. It's not just that it's done during the compile time. There's something done during the runtime as well. So basically it's called as runtime polymorphism. But just to keep in mind, not everything is linked up during the compile time. There's something done during the runtime as well. So it could be distributed as well. You don't have to have all the code put into one machine and run it. from my machine, I could run something written on your machine as well if into net in that same network, or if they're exposed to a network, we could run programs on different machines. So that's what distributed is all about. So you could think of big data. So this is one of the major features why Java is being widely used. The during that it has runtime. VM comes into picture, which we'll talk about. Dynamic, which means that it has runtime polymorphism. So all the objects are evaluated during runtime. It's not just that it's done during the compile time. There's something done during the runtime as well. So basically, it's called as runtime polymorphism. But just to keep in mind, not everything is linked up during the compile time. There's something done during the runtime as well. So it could be distributed as well. You don't have to have all the code put into one machine and run it. From my machine, I could run something written on your machine as well if into net in that same network, or if they're exposed to a network, we could run programs on different machines. So that's what distributed is all about. So you could think of big data. So this is one of the major features why Java is being widely used in big data, right? So big data is nothing but you have chunks of data. You have like petabytes of information coming in every minute or every hour or every day, right? And you want to process it. So it cannot be done in one machine. If you want to run everything on one machine, as we had earlier, right? Everything was monolithic. Everything was done on one machine, sort of. So that's where you would want to have servers, right? Now the server thing is not being used that much since there's a lot of investment and stuff like that. So distributed computing is nothing but we have like peer computers or normal computers that we have, and programs are actually run on these machines rather than having high end machines. So basically this feature is what helps Java to be used in big data. And as I said, it's run on commodity hardware as against server hardware, which needs a lot of investment for companies. Java is multi-threaded. So multi-threaded is nothing but, so you have multiple cores on your machine, right? You have like 4 cores and stuff like that. So you could utilize all these 4 cores. Say for example, you want to do addition of two numbers and multiplication of two numbers, right? Different numbers. So you don't have to run everything on one core. So this could, since you have 4 processors, right? 4 cores, you could have addition run on one core and you could have this multiplication going on at the same instance, right? You could have this multiplication going on as well. You could run them as a thread, right? You don't have to have one waiting for other. You don't have to do it in a sequential manner when you're operating on different variables, right? So that's what multi-threaded is all about. As I said, you could have this operations carried out on different cores at the same instance of time. Object oriented, again, as I spoke earlier, everything is performed using objects, and Java can be easily extended since it is based on object model. and Java can be easily extended since it is based on object model. Now let's talk about which sectors or which industry sectors actually use Java. So you have Android apps. So Android apps could be written on Java. So basically the underneath is Android API, which is similar to JDK. So JDK is nothing but Java Development Kit. It's widely used in financial services industry. If you would have some idea about it, you could see that mostly all financial companies use Java. So all the legacy systems that we have in financial companies is mostly developed on Java. So one of the aspect for this is more about it's pretty secured. So that's why it's been written on Java. Lots of global investment banks like Citigroup, Barclays, Standard Chartered, and other banks use Java for writing front and back office electronic trading system. So one of the main features why it's been used in financial industry is about security. It provides high level of security, as we spoke earlier. Java web applications. So basically, you have web servers on which your application would be hosted, and you could request for a particular JSP, or JSP is nothing but a dynamic HTML page, right? Wherein the contents could change. Basically, you could request for some particular JSP and you could get it. So, say for example, you're trying to log on to a particular application, you get a login page that is nothing but a JSP. So basically, many of the web applications is developed on Java as well. One of the main features why web applications are developed because you have a lot of web servers supporting Java. You just have to deploy your application on a particular web server and could access it from anywhere across globe. You should be on internet though. Embedded system. When it comes to embedded system, it has to be lightweight, right? So Java 8, I remember Java version 8 had a lot of feature making it pretty much lightweight when it comes to embedded systems. So basically you have micro edition J2ME. What we're talking here is J2SE. And the thing that so there are three flavors of Java. So one is J2SE, which is nothing but standard edition, and which is standard edition, which you have like all the data types and stuff like that, all for loops and stuff like that, right? That is about J2SE. You have J2EE, which is enterprise edition, which is nothing but the web application that we spoke about. And we have J2ME, which is micro edition, which is nothing but for embedded systems. As its name suggests, it is micro edition, which is light in weight. And as we can imagine that in embedded system, it has to be lighter since it is burnt into a chip, right? And you cannot have a big application. So that's why we have lightweight when it comes to J2ME. So again, as I touch base on this, it's about web servers and application servers, which makes Java compatible for web applications. So we have Apache Tomcat, which is pretty much widely used, which was a web server earlier. Now they have Apache Tom E, or which is Tom double E, which is nothing but an application server version of it. So basically, when it comes to web servers or application servers, what you do is you as a client could send a request to a web server, and web server or the application server would just process this particular request and send the response the way the application is written. So basically, it would serve the expected result out. So you have enterprise applications. Again, this is Java Enterprise Edition, which makes it favorable for web applications. So all these are specifications, J2ME, J2EE, J2SE. These are nothing but specifications exposed by Java. So if you as a developer wants to do something, or if you want to write your own version of it, you could do it. So where is Java used? Again, scientific applications. So as you could imagine, in scientific applications, you need to have high level of accuracy and precision rather. There could be mathematical equations and mathematical computations, which needs a lot of CPU time because it's very CPU intensive, right? When you do a very precise calculation with high level of high degree, it needs a lot of CPU time, right? So that's where Java is good at. So basically, this is about, as I spoke about, multi-threading, utilizing all the cores to the fullest. So suppose you have 4-core processor, using all these 4 cores is being done by Java. Java has feature, or through threads you could actually read through or actually utilize these 4 cores to the fullest. Big data technologies, again, big data is nothing but, as I said, it's distributed. You cannot have everything run on one machine, which was the case earlier. You would have one server put up and everything is run on that particular server. Now it cannot be the case. That's where big data comes into picture, wherein you have distributed architecture and you have this data being processed across network rather than just on one machine. And mind you, as I said, these machines are commodity hardware and not server level hardware or the enterprise level hardware, which makes it cheaper. Internet of Things. So, Internet of Things is coming up, is a booming thing wherein you could connect things together. Say, for example, you have cars, right? So, you could connect cars together. So, you could have sensors in your car which could emit data and you could connect them together. So, basically, it's all connecting things together. Or say, for example, let me talk about internet itself. So earlier, if you remember, computers were not connected. It were all peer, right? It could just be used for your own purpose. Now internet has started wherein you have all these computers connected, and if you are connected to the internet, you could go on to Google and search something or whatever you want to, sort of. So basically, this is what Internet of Things is all about. So consider this, instead of computer, it could be any other object, say car, for example, as I said. So consider car has sensor and it is emitting this sensor data every minute, and we could utilize this sensor data and do something with it. Or one car can know where the other car is. So that's what Internet of Things is about, all about, connecting things together. Let's start off with the setup for Java. So basically, you could go to this particular site and just download the SDK based on your, since it's Windows, which it's pretty safe. I get into the JDK and one folder in C, which you have to run. So here it is particular. So it's basically give you IntelliJ, whatever you are comfortable with. So you could use either of them. Since IntelliJ has much more features, you could use IntelliJ as well. So you go to Eclipse download, and whatever flavor, you can take the latest one, whatever flavor you want to install. If you want a simple one, you can do it. If you're trying to do something on web, you can download that one as well. So basically, for simple purpose, for whatever we are going to do, you can have normal ones. So let me quickly open up my. So this is nothing but the IDE, integrated development environment, that I use, which is IntelliJ. All the IDEs are pretty much similar. So IntelliJ is similar to Eclipse. So it's coming up. So basically what you do is you have to select a workspace first. Workspace is nothing but all your program, all the class files, all the class and everything that you write would be put into this particular workspace. And you can create a new class and start off. So when we get to the Hello World program, which is the first program that we are going to talk about, it would give you a clear idea on what we are talking about. So let's talk about Java internals, how it looks like, and all the features that we spoke about. So basically, so far what we have covered is more about Java is an object-oriented program, or it uses object-oriented programming paradigm, which is nothing but everything is thought of as a class with a particular state and behavior, right? It's platform independent. That's why it's been widely used. It's secured as well. That's why it's been used in banking applications and stuff. It's good for distributed computing since it's platform independent. You just have to write it once and you can run it it everywhere. So basically, this platform independent aspect is what helps it to be widely used in big data applications. So let's talk about the internals. So what is JVM? JVM is nothing but, again, it's a specification, right? You could have your own JVM. Sun by itself gives specification for a JVM. This is what the JVM should be all about. So I could create my own JVM, but we use the reference implementation of Sun Microsystems or Oracle now, right? So JVM is a virtual machine that runs the bytecode. So basically, there has to be some level of compilation done before JVM can understand it. So that's where you have Java compiler. And so what this does is nothing but it takes your source code, it takes the class files as, or it takes the class that you write as is. So Java compiler would consume it and kind of compile it into a dot class file. So dot class file is nothing but compressed version of it and compiled version of it as well. And this dot class file is nothing but it's also known as bytecode, and this is what a JVM could understand. So once you have this class file, it could be sent to the JVM, and JVM could understand it and run the applications. So what makes Java platform independent is this Java compiler is platform independent. You don't have to take care about it. You just have to run the compiler. And whenever you want to run this particular bytecode on any of the machines, you just have to have JVM for that particular machine, right? So basically, if you want to have on Linux, right, if you want to run it on Windows, you would have JVM installed on Windows, or you would download the JVM for Windows. And if you want to run it on Ubuntu or the Linux or Mac, you would just have to have the JVM downloaded for that particular platform, and it should be able to sense this particular bytecode. So basically, this is what makes it platform independent, right? As I said, once you have this bytecode, once you compile it, this bytecode could be transported or ported into any of the machines, any operating systems, and you should be able to run it. That is what it is all about. It's write once and run anywhere. So as I earlier mentioned, you could just get this class file into your pen drive and take it anywhere, and you could just plug your pen drive and just run through. That's how simple it is. So this is Java runtime environment wherein you have a set of JVM plus you have libraries. Libraries, it is nothing but, all the programs put together, all the program source code for Java put together. So rt.jar is one of the libraries which would have most of the classes, or you have util classes, maybe string class. String is a class itself, which is exposed by Java. So this particular jar file, or it's a Java archive. Jar is nothing but Java archive, which is set of Java classes, or the class files rather, which would have a lot of class files within. So in rt.jar, you would have something like string class and stuff like that. A lot of other classes which is being used by the system, or which is being used by Java itself. So basically in JRE, this is what you have: JVM plus set of libraries plus other additional files. So as spoke, JVM is nothing but specific to environment, but all these things like rt.jar and stuff like that would be independent. JRE does not contain tools and utilities such as compilers or debuggers for developing applets and application. So JRE by itself is a runtime environment, so it doesn't have compilers and stuff like that. runtime environment, so it doesn't have compilers and stuff like that. So JDK is nothing but it's specifically for development. You could see here it's JRE plus development tools. You have compilers and stuff like that as well. So to run a class file, you just need the JRE, but if you're a developer, you would need JDK. So what we downloaded earlier, if you remember, that was JDK, right? JDK for Windows or JDK for Linux. So basically, if you see this one, you could see here as JDK. So essentially, you need JDK only if you're a programmer. If you just want to run the class file, JRE would suffice. So what is JDK, JRE, and JVM? As we spoke about, you could see JDK is a superset. It has everything, right? JDK would have your JVM plus it would have, as we spoke here, it's JRE plus your development tools as well. As you could see here, details, it has everything here. It would be really confusing right now if you directly get into what all this is all about. But basically, you could imagine JDK is a superset and JRE is nothing but it's your runtime environment, which has JVM and some additional files, or rt.jar as we said, which is nothing but set of files, set of class files that is exposed by Java, which could be used, like string, for example, right? Let's see how it works. So basically you have your source file. So this is what a developer would typically write, would create a .java file. So whatever you write, you create a class, you just create a new class and write something to it. What you get is .java. You get the extension .java. So basically this is your source code, whatever you write, you as a developer would write. This class files would be sent for compilation, or whenever you are good enough done with your coding, you would compile it. And once the compilation is done, once everything looks good enough, once the compiler doesn't mark anything and doesn't flag anything rather, which means everything is syntactically right, you would get Java bytecode, which is nothing but .class file. Now this .class file could be moved across network, or you could, as I said, you could just put it in your pen drive and can take it anywhere. And you could run it on any of the environments. You just have to have JVM. So basically, you could run this class file, which is compiled on Windows. You could run it on any of the environment, any of the platforms. So this is something that we spoke about during runtime. There's a verification as well. So when class loader would load this particular class file, it would ensure that it is up to the mark or it's not manipulated sort of. So if it sees something wrong, then it would flag it off as, corrupted file or something. So this is nothing but Java class file libraries, rt.jar that we spoke about, Java archive. So this is what is happening when you run a particular class file, right? So you have this class loaded and then you have this compilers, just-in-time compiler actually running it for you. So basically it's a part of JVM. So remember JVM is nothing but it's a platform. It is specific to platform. So basically for Windows, you would have a different JVM, and for Linux, you would have a different JVM. So yeah, you get this class, you load this class using class loader, and you run through the application or run through the class files. So typically this is how Java operates. So just to give a gist on this one, so you have a source code, you have .java file written, you compile it, you get a .class file, and you can port this class file anywhere. You can run this class file anywhere on your network or wherever you want to. You just have to take this class file, and on the machine on which you run, what would happen is you load this class file first using class loader, and with JVM would have just-in-time compiler which would run a particular class for you, right? So what we are trying to do here is you're running the source code that's written on any environment, you're running it on any other environment. So basically you could write this on Windows, you could write source code on Windows, but you could run it on, say for example, Linux. So that is what makes it platform independent. So yeah, let's create one class, and as we create it, I'll talk more about it. So you could open up your Eclipse and could create something like new project. So it could be a bit different for you. The look and feel might not be exactly the same as mine, but you just have to create a new project. Select Java. So basically I put a project name, so whatever you want to. So basic nomenclature is like it has to start with uppercase letter, which is camel casing, right? So you should follow camel casing when you, that's one of the best practices. It won't flag you as some error or something, but that's a normal industrial practice that whenever you create a Java project, it has to use camel casing. Create Edureka Java. So it's creating a project for me. And as you can see here, I have this particular project being created, right? Now what I do is I create Java class. So basically, as we said, everything could be seen as a class, right? That's what object oriented is all about. So basically what I would do is I would create a class here. So this is my source folder wherein all my source class would be there. So as you can see here, new Java class. So say I create com.edureka. So this is nothing but your namespace of the package, right? So you could give whatever you want to. Basically, this is to avoid collisions, right? If we don't have a namespace, there would be a lot of collisions within the class. So there are a lot of people working on the same project, right? So I could create a class with name class A, and the other person might create class A as well. So when this is clubbed together into one particular application, there would be a collision. So to avoid this, basically what you have is you have a namespace. So I would write as com.edureka.class A, and the other person would write something else, and that would avoid class name collisions or class collisions. So this is com.edureka is my package or namespace, and hello world is my Java. See here, there's a package com.edureka, which is again a namespace, and there's a class by name hello world that's been created, right? And if you want to see, you could actually go and so you can see a folder structure created here in the source. So this is your source folder, right? Within your project, there was a source folder wherein we created the class. So if you go to the source folder, you could see a package structure or you could see a directory structure being created, which starts with com, and within com you would have edureka, and here you can see hello world.java. So remember we said that your source code would have all the Java files. So basically this is what I was referring to. This is a method, that's a default method that's been called. So when you run this particular class file, JVM would actually look out for this particular method. So you need to have the same signature as is. So you would have a main method wherein your program execution would start, right? So as in when you compile it and run the class file, so basically when you compile it, you would get a class file, right? And when you run this class file, JVM would check out for this main or a method that has the same signature as this one. That's a main method. And your program execution would start running from here. So basically it's an entry point for your execution, right? So this would be a simple program wherein we would just print hello world. So basically you have like system is a class, and this is how you print in Java. So I don't want to confuse right away by saying what is system, what is out, and println. But basically, what you have is system is a class. As I said, everything could be imagined as a class. So in Java, everything is a class. So basically you could just click here and you could see the source code of it, right? This is the source code and this is coming from rt.jar. Remember in JVM we spoke about, in JRE we had rt.jar, we had JRE, we had JVM plus class files. So all this has been written by Java, by the Java community. So basically you can see here this system itself is a class. So out is an instance variable and println is nothing but a method within out. So what this statement, particular thing is doing is nothing but writing it onto your console. So let's print hello world. So basically when you build a project, it's compiling it. As you could see here, it's saying it's building it. So once it has built it, you could see a class file here, right? So you could see here hello world.class. This is because we built it. When you build it, your Java file would be compiled by your compiler and it would create a .class file. And remember, as I said, this .class file could be run on any machine. So this is Windows machine that have written this file, Java file, and compiled on. Now this .class file could run on Linux or any platform that you want to run it on. So let me talk about this class, right? So you have a public keyword, which is nothing but access modifier, which gives visibility. So basically what we are trying to say here is hello world is could be publicly seen. So it could be seen anywhere within the application. So basically for class level, you have public, which as the name suggests or as the name gives out, it could be seen anywhere within your application. That's a visibility key access modifier. All right, so you have the keyword class here, which is for the class. You need to have it mentioned as class. If you write something else, then it would give you compilation error. So it has to be exactly the same. All right, that's the syntax of it. Hello is nothing but the name of your class. Then you have this public static void main, which is nothing but, as I said, this is the entry point for your application or your class file. So when you run this particular class, it would start off from here. You have a static keyword. Static keyword is nothing but it's at the class level. So basically you need not create instance. We haven't reached to that point yet. So basically hello is a class and you could create instance of hello, which is nothing but object, right? So when you have a static keyword here, you need not create object of hello to run it. If it's not static, then you need to have object of hello created. So basically what I'm trying to say is, say you have one more method here, which is test. Now this doesn't have a static keyword here. So basically what we can do is we can print. So yeah, this is a non-static method, right? Now we cannot call it directly. If it's a non-static, you need to have an instance of hello world created. So basically how you create instance is nothing but hello world. That's your hello world object. So when I say instance, I'm talking about creating object, right? And you could create new hello world. So object of hello world is created using new keyword, right? When you do this, you would get an object of it. Or now what I do is, so basically what I was trying to say is you cannot call test as is. If you do it, you would get a compilation error saying that non-static method test cannot be referenced from a static context, right? You cannot call it without having your object. So basically I can call it on hello world object dot test. Now I can call it. Now it doesn't give me compilation error. I'll create one more static method which would give you some idea. So I'll rename this as non-static test and this would be static test, right? And we are printing a static method and here we are printing non-static method. So hello world dot non-static test. Now whereas the static test did not be called using object. So we could directly call static test. Sorry, I haven't written static here. So this is a static method. Okay. So now you could see here it compiles fine, right? So what I was trying to say is when you have a static method, you did not have an object to call it, whereas non-static method, you need to have object. That's what the static is all about. Then you have void is nothing but the return type. It's not returning anything from here, so that's why it's void. You have main method, that's the keyword, that's the entry point for your application. You have this arguments. You can see string array of strings, which are arguments provided to a particular program. So you could pass on as many arguments as you want. Or if your program is, say for example, you want to pass your name as an argument, you can do that. So this is arguments. Then we have main, which represents startup of the program, which I already mentioned. Then we have system.out.println is nothing but the print statement. So as I mentioned, system is nothing, everything could be thought of as a class. System is a class, out is an instance variable, and println is a method within out. So basically you don't have to think much about it. Just to understand the structure of it, just to understand how a particular class is being written, this is what we have. This is how we write a class, right? Again, just to brief on this, you have access modifier, which denotes the visibility of a particular class. You have the class name. You have the main method, which is nothing but the entry point for your class. You have a static method, which says whether you need an object to call a particular method or could be called directly from a class. You have a return type here. So this is how typically any method would be written, and you can write whatever statements you want to within this particular method. This case, we have printed out hello world. So basically you could follow this when you do it on Eclipse. World. So basically typically any method would be written, and you can write whatever statements you want to within this particular method. In this case, we have printed out hello world. So basically, you could follow this when you do it on Eclipse. So it might be a bit different based on the Eclipse version that you would have, but it should be pretty much similar. All right, so you create a new Java project. So I showed this already on IntelliJ, which is also widely used IDE, but yeah, you could use Eclipse as well. So basically, you could see the project name being written as Hello World, right? And here it mentions the JRE to be used. So here you can see class being created. And let's see how we can run this. So we compiled it and we saw that .class file was created. Now we can run this. So as I said, main is the entry point. So it would start running from here. So your program control would come here. And the first thing that it would see is you have printed hello world. So it should print this one. Then I would keep it simple. I don't want to, let's see what's been printed here, right? So you could see here hello world being printed first, right? This is where the program execution started from. So it came to main, saw hello world, it printed out hello world. Then you gave a call to this non-static method. So it printed non-static method, which has been printed in this particular method. And then it gave a call to static method, and you could see static method being printed here. So one thing to remember is the program execution starts from main, and it just executes this main method. So whatever content you want to write, you would basically write it in the main method. So you could see here hello world being printed out. Now let's see how easy it is to code the same in the J shell. So J shell is nothing but shell prompt as well. So yeah, instead of here something to the main and then run it and stuff like that with J shell. So one thing that we saw in the program was access modifier we already saw about, actually this one, right? Public, and we saw public here as well. So these are nothing but modifiers, right? Public, as I said, this public means it's an access modifier which shows that hello world could be accessed anywhere throughout your application. So here we can see is a word or a phrase, changes meaning of other phrase in some. So basically it's just trying to say that one of the aspects or one thing that access modifier could be used is to control the visibility of a particular class or a method as well. We have an access modifier for your methods as well. So this is just one of the things, right? We would see other modifiers as well. Modifiers in general has some other things as well, but when it comes to access modifiers, It basically controls the visibility of a class, or a method. Or so yeah, modifiers here, as you could see, there's access and non-access modifiers. Let's see access modifier. There's access and non-access modifiers. Let's see access modifiers. So we used public already. So this one is nothing but a access modifier, which is public, which says that it could be used throughout the application. So visible to the world, as it says. Public is nothing but visible to the world. If we talk about chronological order, if we talk about the visibility, so default is visible to the package. So default is nothing but within the package, it would be visible. So basically you could default is without any keyword, without any access modifier. That's a default scope. So within the package, it would be accessible only within the package. So you have like com.edureka, that's your package, right? So this hello world would be accessible if it has a default scope. It would be accessible only within com.edureka. If you try to access it from some other package, you would get an error. So that's the default visibility, visible to the package. Private is nothing but it is visible to the class. It is only visible to the class. So this is the lowest visibility, only visible to the class. If you try to access it from outside class, even within the same package, you would get an error because you won't be able to access it. It is accessible only within the class. Public is accessible to the world. It could be accessed from anywhere within your application or anywhere within your wherever your class file. So basically, if you have a jar file, but what I'm trying to say is public is accessible anywhere, right? Protected is again visible to the package and all the subclasses. So we'll talk about subclasses. So subclasses is nothing but in C we have inheritance, right? Say for example, integer. Integer is a class. So as I said, in object oriented paradigm or in Java, everything could be visualized as a class. So integer itself is a class, right? So there's a number, there's a superclass, which is number, which has all the common state and behavior that a particular number would have, right? So number is a superclass, and you have subclasses like integer. Float would be a subclass of number. Long would be a subclass of number. Basically, this is inheritance, right? You are inheriting integer, float, long, double, and everything from number class. So number is a superclass, and all this integer, float, and everything is a subclass of number. So when it comes to protected, it says that it is visible to the package and all the subclasses. So just to keep in mind, as of now, you can think of access modifier as visibility of a particular component, or could be visibility of a class or visibility of a method or an instance variable as well. This is what drives the encapsulation factor of object-oriented paradigm. So basically, we control the access for all these components, or we control the access of class, variables, methods, and everything, which makes it encapsulated. Cannot be breached, sort of. As we could see, this is like I could make this one as default as well. All right, so this is default scope. It would still run because it's within the class. Right now, suppose I make this one as private, right? Just to show you what this encapsulation is all about, or what this access modifier is all about. Suppose I make this one private, right? Still this one runs because it's within the class. You're trying to access it within the class. Now I create a new class. Say for example, we say access modifier test. So I create a main class here again, main method. Now suppose if I try to run this, right? So basically I create the same stuff here. Say I create a hello world object. Okay. Now this one is private, right? Now if I try to access it from here, what I was trying to say is if I gives it default scope. And as we said, default is nothing but it has got access within package. You could see this error going off here. Now it is accessible, right? So that's what it is all about. When you have a private scope, it's within a class, whereas default is within a package. Public is accessible anywhere, and protected is visible to the package and just the subclasses. So let's talk about non-access modifiers. This is not controlling the access of class, method, or variable. When it's static, you need not create object of a class. So variable. This is not controlling the access of class, method, or variable. When it's static, you controlling the access of class, method, or variable. When it's static, you need not create object of a class. So basically for static test, you could see that we didn't create object of a class. We didn't call static test on a particular object of a class. It could be called directly. That's what static is all about. The static modifier for calling methods and variables without an object to which it belongs. As we saw, we didn't create an object of hello world. We directly call the static method. Final is nothing but you can't change it. Final, as the name suggests, you can't change it once it is created. So finalizing the implementations of classes, methods, and so this is nothing but instance variable, which we would be talking about the slides to come. Just to tell you, this is instance variable, which we have assigned the value 10. Now, suppose within this particular method, I try to change the value to 11. You would get an error saying that cannot assign a value to a final variable. So final is like it's final, can't change it. Once you have created it, you can't change it. But if I remove this final, you could see this error would go off. You don't see this error anymore. Whereas by putting final, you would see this error. So that's what final is all about. So basically, this is good enough for constants, right? So if you have constants within your class, you would make it final so that no one can change it. Abstract is nothing but you could mention it as abstract when it doesn't have implementation of all the methods. So what I'm trying to say is abstract modifier is again a non-access modifier. And what it tries to say is, say for example, you have a shape class. Shape class is an abstract class because shape doesn't say you want to calculate area of shapes. So basically shape class by itself wouldn't know what the area of the shape would be. Shape is a class wherein it's a generic class. It doesn't know what the implementation of area would be. For square, it would be side square. For rectangle, it's length into breadth. Or circle, it's pi r square. So basically, shape by itself wouldn't know what its area would be. But now shape is a superclass, and say you have subclasses of it, like square, you would have circle, and so on. So now basically, you want to ensure that when you create a subclass of the shape class, you want to ensure that that particular class implements the area. That's when you create it as abstract. So the shape method would have, or the shape class would have area method as abstract, which would be implemented by the subclasses, which has to be ensured. It's kind of ensuring, or if the subclasses don't actually implement it, you would get a error. So basically, circle would have its own implementation of area saying pi r square. Square would have its own implementation saying side square. So basically what I'm trying to say is area is a abstract method for shape class. And when you have an abstract method, the class itself is abstract. So you have like shape com.edureka.shape. I'm creating a class. Now I'm creating an abstract method. So when you say abstract, you don't have to provide implementation. It's just a generic this thing. You don't have implementation of it. You just have the signature of it. So basically, as I said, when you have an abstract method, the class itself should be abstract. So we'll have to make this abstract as well. So you created a shape class which would have an area and which would give you this thing. So basically, if you want to have subclass, I don't want to show how the subclasses are created at this point, but basically this is what abstract is all about. You don't have the implementation of it, but you're ensuring that subclass is implemented. So here you can see it's just a signature. You don't have implementation unlike this. Implementation is nothing but if you write something within these braces, this is an implementation for this particular method. Whereas in shape class, you just provided the method signature, but we don't have implementation of it. So that's what abstract is all about. Synchronized and volatile is much about used in threads. Synchronized is we are saying that only one thread could get a control at one point. So as we said, threads are nothing but parallel execution. You could have thread, say for example, you could have thread one calling a method. So we have a non-static method test, right? Say this is a method. So what we are trying to say here is if it's synchronized, we can make this as synchronized, private synchronized. So this is what ID is all about. So when you have this integrated development environment, you don't have to type everything. When you type SY, you could see synchronized coming up here and you could select it. So when you put a synchronized here, what we are trying to say is only one thread could access it at a given point. Only one thread at one point. So if multiple threads are trying to access it, one thread has to wait for it. So only one thread would get an entry to this and the other thread should wait for it. So that's what synchronized is all about. And volatile, it's basically for memory visibility, or what we are trying to say is, so basically every processor has got its own cache. So what we are trying to say is when you use a volatile access specifier, don't store it in cache, store it directly into the main memory so that all the threads would get the most recent value being assigned to a variable. And also volatile is not needed when you have using synchronized as such. So it's mutually exclusive. So let's talk about variable. So variables are nothing but it's a holder, right? It holds value, and variables are nothing but it's reference to that particular or it's an address or something that is pointing to a memory location where the values are being stored, and you could access it using this particular variable name, or you could access the memory location where the value is stored using a variable name. What I'm trying to say here is, so this is a variable and you could access, so this 10 is stored somewhere in the memory and you could access this part of memory location where this 10 is stored using this variable. or you can manipulate it as well. You can change the value. So basically, there are three types of variables in Java. There's local, instance, class, or static. Local is nothing but local to your method. Whenever you have a method or you kind of create a variable within a method, that is nothing but local scope, which is like it has the access, its visibility only within that particular method. Once control goes out of this method, you can no longer access this particular variable. That is local. So if I define something here, say for example, I define something here. So this is a local variable since it's defined within a method. So once the control, you would have this only within this particular method. Once the control goes out of this method, this is no longer accessible. Basically, this is where garbage collection for Java is useful. Once your control goes out of this particular method, garbage collector would kick in and would clean up this variable or clean up this particular memory location or would make it available for use. So that's the local scope. The next one is instance. Instance is nothing but something that is defined at the instance level. So this is instance variable. So since it's at the class level, right? This is, you could see it at the method level. This is at the class level. So this is nothing but an instance variable. Now there is static variable as well. So this is how you define a static variable. So instance variable is nothing but it's per instance. So you could go and change this instance variable to something else. Suppose I assign a value 40 here. Now I could have one more object created. Suppose I call this object 1 and I have hello world object. So I create one more object here. So what we are trying to do is we are trying to change the instance variable through objects. So basically this is what it is. When you have an instance variable, normal instance variable, which is non-static, you could access it through objects, right? So through object one, you assign for object one, you assign instance variable value to 40. For object two, then you change the instance variable value to 50. I won't say changed it, but you assigned it. This is how you deal with instance variable. It's at the instance level. It's at the object level. Whereas for static, it's at the class level. It's one per class. It's not one per instance. It's one per class. So basically what you can do is you could do something of this sort, wherein it's at the class level. It's not at the object level. You are assigning value 100 to a static variable. So as you could see here, it's not a particular instance that you're operating on, it's the class directly. Just to give you a gist, we have local variable, which is within a particular method, and scope remains within a method. Once the program control moves out of this particular method, Java would or JVM would come in and kick in garbage collector to clean this off. It's only accessible within this method. You have an instance variable, which is at the class level, but it's non-static, and which means that it has copy per object. When you have multiple objects, you could change the values the way you want per object. Static is nothing but one per class. And as you could see here, we changed the value of the static variable to 100 through class. So that's about variables. We have an instance. So instance variables are declared in a class when the space is allocated. I'll just read through this one. So when a space is allocated for an object in the heap, a slot for each instance variable is values created. We had a teacher instance variable, and whenever you create, but basically an instance of a class is created in a part of a memory which is called heap. So whenever hello world object is created, a slot for this instance variable would be created as well. Instance variables are created when an object is well. But table is basic table with kick and index, but uh, I'll just read through this one. So when a space is allocated for an object in the heap, a slot for each instance variable is values created. We had a teacher instance variable, and whenever you create, but basically an instance of a class is created in a part of a memory which is called heap. So whenever hello world object is created, a slot for this instance variable would be created as well. Instance variables are created when an object is created with the use of keyword new, and destroyed when the object is destroyed. So unlike local variables, which is within the method scope, instance variable is within the class scope. So basically, whenever you create an instance of a particular class, your memory instance variable, and whenever it's done, whenever it's destroyed by the garbage collector, it would go off. Access modifiers can be given to instance variables. You could have like private, public, protected, default. All the access modifiers be assigned to an instance variable. So basically, you could have it as private. Private is just within this class. You cannot access it outside this class. You could have public as well, which is like could be accessed anywhere within this application. You could have protected, which is like within the package or the subclass, and you can have the default one, which is nothing but package access, which would be accessible just within this package, that is com.edureka. So instance variable have default values. For numbers, the default value is 0. For boolean, it is false. And for object references, it is null. So values can be assigned during the declaration or within the constructor. You could assign values directly while declaring it, something like this. Instead of 0 is the default one for integer, as they have mentioned. But yeah, you could assign, if you put it as 10 here, it would be taken as a default value instead of 0. Constructor is nothing but a method which constructs an object of a class. Values can be assigned during the declaration or within the constructor. Instance variables can be accessed directly by calling the variable name inside the class. However, with static methods, when instance variables are given accessibility, they should be using fully qualified name. So what we are trying to say here is this is a static method from which we are trying to access instance variable. In this particular static method, you need to have object reference. This is the object that we created. So object reference dot instance variable. You need to have, as we have mentioned here. So here, as we can see, object reference dot variable name. You need to have fully qualified name. When you try to access it within the static method, you need to have fully qualified name. Whereas here, within a method which is non-static, this is non-static. Here I can access instance variable without object reference. So here, as we can see, it could be accessed without. But if I do it here, it would throw me an error. It's not accessible here at all. Non-static field instance variable cannot be referenced from static context. Instance variables are not accessible directly here. It has to have fully qualified this thing, which is object reference dot instance variable. Whereas when it's called within non-static method, you could use it direct. So static, as we spoke about, it's one per class. So it's declared using static keyword. So static variables are stored in static memory. It is rare to use static variables other than declared final and used as either public or private constants. As we said, it's mostly used for constants, and static variables are created when program starts and destroyed when the program stops. So one thing to remember is it's one per class. It's not one per object. Instance is one per object. You have a copy of that particular instance variable, one per object case of instance, whereas case of static, it is one per class. So the scope remains, or the life cycle cycle remains right when the class is loaded till the program is stopped, till the class is unloaded. Static variables are declared public since they must be available for users of the class. It's not mandatory though, but usually if it's a constant, it is declared as public. Static variables can be accessed by calling with the class name. So we saw here class name dot static variable. So how do we decide what amount of memory is to be allocated? So these are the data types that we have. So each variable in Java has a specific type which determines the size of memory, the range of values that can be stored, and the set of operations that can be applied to the variable. Data types can be categorized into two major types, primitive and non-primitive. So basically primitive is not object. Primitive is supported by language itself, which is kind of, it has got 8 primitive, or it's predefined by the language and named as keywords, and it has 8 primitive data types, that is byte, short, integer, then you have long, float, double, character, and boolean. This is pretty much similar to other programming languages that you have. Byte, it consumes one byte. These are 8 primitive data types that are predefined. Non-primitive is nothing but string. String is an object itself, so that's something that is non-primitive. Or if you define your own class, say student for that matter here, right? We have defined student class, that's non-primitive. So the student class is non-primitive. We have strings for storing string, which is again kind of non-primitive. We have arrays, or basically it's all called as reference variables, since we're referencing a particular memory location through variable name. This is where we have table showing byte consumes 1 byte and its range is from -1 to 8 to 1 to 7. Short is like 2 bytes, and you could imagine that it would be from -32768 to 32767. So it's pretty much similar to other programming languages that you have, like in C as well. We have similar to this thing. One thing is character takes 2 byte, in C it takes 1 byte, I believe. Though it doesn't use all the 2 bytes every time. It depends on encoding type. So Boolean is 1, which is true or false since it has to store 1 or 0. So yeah, it's pretty much similar. So just to talk on the bytes required, byte is 1 byte, short is 2 bytes, integer is 4 bytes, long is 8 bytes, float is nothing but it has decimal values stored, signed decimal values. So it again consumes 4 bytes. Double is signed again float values or signed decimal values, which consumes 8 bytes. Character is 2 bytes, and Boolean is 1 bit. So basically, to decide whether to use float or double depends on the nature of the application. So if you want to have more precision or if you want to have more range, you could go with double. So non-primitive or reference data type is a variable that holds a particular object or holds bit that represents a way to access an object. It's a pointer to a memory location basically. So as we spoke, Java doesn't expose the pointer directly. It doesn't give you directly pointer to the memory location, but it gives you the reference variable. So you cannot manipulate memory location directly. You cannot add some values to the memory location through pointers or something, but through reference variable, you can access it and assign some value. So yeah, it does not hold the object itself, but it holds a reference address to the object. The reference type does not have size or bit range. So here we can see string str is equal to edureka. So the one shown in red is actually the memory where edureka is stored. You have a reference and str is the reference to it. So here we can see variables and data types. So we have a main method again, and we have byte. We declare a byte here. Byte b is equal to 10. Short s is equal to 20. So I think it's pretty straightforward. you kind of have this data types created. You just have to assign values to it. These are all primitives, as you could see. Till here, it's primitive. So you could see that values are being assigned and it's been printed out here. So I think it's pretty straightforward. You can assign a value to a variable and just print it. So again, we use system.out.println for printing it. You could try it out on your own. You could try it out this data type program. You could just assign something and just try to print it out. We are talking about data type conversions. So we have implicit and explicit conversions. In some case, programmers don't have to actually write explicit conversions from one data type to other, but in many cases, programmers need to. So the arrow in the diagram shows the possible implicit type casting that are permissible with primitive data types. It's just with primitive data types, right? As the diagram shows, int can be converted implicitly to long, float, double. Since int takes less space, it could be applied to any of the numbers. For vice versa, they have to be converted explicitly. Whereas if you want to convert long to integer, you have to mention it explicitly. So basically, we are talking about when you're trying to store integer into long, integer takes less space and long takes more space. So it can be easily accommodated. Since long takes more space, if it is more than the range of the integer, it wouldn't know how to assign it to integer. So that's why it has to be explicitly converted. Implicit conversions, we can on the J shell you could type this. So here what we are trying is we have a character C is equal to A, and you could see C is assigned A. Now integer K is equal to C, which could be done. You could assign character to an integer. So basically it's a ASCII code for it. So 97 is the ASCII code for C, which would be assigned to K. So now when you assign C to float, which works as well, so you get 97.0. You could assign character to long as well, which is 8 bytes integer. You could assign double as well, which is 8 byte float, and you could see. But it cannot be done the other way around as we spoke. So you cannot have integer or you cannot have double assigned to character. So it would give you incompatible or possible lossy conversion from double to character. It has to be explicitly done if you want to do that. Need of type conversions. So here we have integer a equal to 100, initiated a variable with type integer. Then you have a string b, which is assigned value hello. The data type of both the variables are different, but to perform any operation, we need both the variables to be of same type. Here, integer value is converted into string and gets concatenated with other string. So basically, had b been an integer, you would have got addition of it. Say, for example, integer b is equal to 200, and if you 100 plus 200, you would get 300. But since it's a string in this case, 100 is converted into string and it's concatenated with hello. Explicit type conversions. We saw the previous case wherein double was being assigned to character, which prompted us with lossy conversion. So this is similar to that. So basically here what we are trying to do is we are trying to assign double to integer. So you have double, d is equal to 45d, which is 45, right? Again, double is 8-byte decimal signed decimal number. So you assign 45 to it. And now we are trying to assign this double value to integer. So it's possible lossy conversion. But you have a provision to typecast it. So basically what we are trying to do here is you're trying to assign again double to integer, which is possible if you typecast it. So when I say typecasting, it's nothing but opening parenthesis, then the destination data type, then your data, actual variable. So basically to the right side, you could see that through explicit typecasting, we can assign double to integer. So casting may lose information. For example, floating point values are truncated when they are cast to integers. Example, the value of d, that is 45.5, when converted to integer gives 45. So we could see here in the bottom, like the double, we assign the value of 45.5 to double, but when we converted into integer, we got 45.5 was truncated. Since integer, since the destination data type that's integer doesn't store decimal values. Now this is like type conversion methods, which is there in your wrapper classes. What we are trying to do here is we are trying to convert 23, which is string, into integer. So you have a string s is equal to 23. You assign the value 23. So mind you, this is string right now. We have integer.parseInt and we pass the string, which would be converted into integer. So this integer class that you see here, right here, is nothing but a wrapper class. You have string into integer, which is nothing but integer.value of string, which converts it into integer data type itself. So as you could see, the destination is integer. Now integer to string, you have integer. We have a toString method which converts integer into string. So basically you have integer I, which has been assigned 23. Now you have integer dot toString I, which would convert this integer into string. We have one more method, which is string dot value of, which would also convert integer into string. Let's talk about operators. Operators are nothing but it operate on these data types. So you have unary, which is kind of pretty much similar to what you have C, C++. You have postfix and you have prefix. Postfix is I++ or expression++, and the operator is after the variable, which means that it would be assigned value and then it would be added. Prefix is before the operator, which would be added first and then assigned, or the operation would be done first and then assigned. That's prefix. Arithmetic is pretty much similar, like multiplicative. You have like multiplication, division, and mod. You have additive, which is plus and minus. You have shifting operation, which is bits shifting to the left and bits shifting to the right. You have relational operators, less than, greater than, less than, equal to, greater than, equal to, instance of equality of two data types or two variables, which check whether they're equal and not equal. We have a bitwise and bitwise XOR, bitwise inclusive OR, which is happening at the bit level. We have logical and logical OR. So basically this is for conditions, right? If you want to have like two conditions, like if int I is greater than 0 and int j is greater than 0, sort of you add or you have logical anding between two conditions, logical conditions, or logical or pretty much similar to other programming languages, like it's or between two conditions. We say that either this or that. We have a ternary operator which says that if the condition matches, we would have a condition followed by question mark followed by colon, and we would have some value followed by colon followed by some other value. So what we are trying to say here is, if the condition is true, assign value 1. If the condition is false, then assign value 2. So instead of having it written in if else, you try to put it within ternary operator. So basically, this is when you have simple assignment operator. If you have a logic, if you have some particular logic being written, it would be a better practice to have if else so that it's readable, right? Because ternary operator, it would be very difficult to actually read through.